There is a bark that insulates better than fiberglass, resists fire without chemical treatment, and regrows every 9 years from the same tree for 200 years. The building insulation industry generates $60 billion per year, selling you petroleum-based foam instead. The bark grows for free. The industry writes the building codes. Your walls contain the foam. The tree is Quercus suber, the cork oak. It grows across Portugal, Spain, Morocco, Algeria, Tunisia, southern France, and parts of Italy. Its natural range follows the Mediterranean climate band: hot, dry summers, mild, wet winters, poor rocky soils where other oaks struggle. The cork oak thrives precisely where agriculture fails. It asks nothing of the land. It returns everything. The bark of this tree is not like the bark of any other tree on Earth. It is composed of a honeycomb of microscopic 14-sided cells, 40 million of them per cubic centimeter, each cell sealed, each cell filled with trapped air. Air is one of the finest thermal insulators known to physics. Cork does not insulate because of chemistry. It insulates because of architecture. 40 million air pockets per cubic centimeter, arranged in a geometry so precise that heat cannot pass through efficiently in any direction. No factory has ever replicated this structure. No synthetic foam has ever matched its cellular density. Nature solved the insulation problem 300 million years before humans built a wall. The R value of expanded cork insulation board is 3.6 to 4.2 per inch of thickness. Fiberglass batts, the standard residential insulation installed in 90% of American homes, rate between 3.1 and 3.7 per inch. Cork matches or exceeds fiberglass at identical thickness, without a single chemical additive, without formaldehyde binders, without petroleum, without glass fiber that shreds lung tissue on contact. The bark of a tree that is never cut down outperforms the product that fills your walls right now. But thermal resistance is only the beginning of what this bark does. Cork does not ignite below 485 degrees Celsius, 905 degrees Fahrenheit. When exposed to direct flame, the surface carbonizes into an ash layer that insulates the interior material from further heat penetration. It does not melt. It does not drip flaming material onto surfaces below. It does not release hydrogen cyanide. It does not release carbon monoxide. It does not propagate flame laterally along a wall. Fiberglass melts at 1200 degrees Fahrenheit, but its formaldehyde binder ignites at far lower temperatures and releases toxic gas. Spray polyurethane foam is flammable and requires a 15-minute thermal barrier covering to meet code. Polystyrene rigid board ignites readily and produces cyanide gas when burning. The building code approves all 3 of those products for residential installation. Cork, which does none of those things, which passes every fire test thrown at it, is classified as an alternative material requiring special engineering approval in most American jurisdictions. The cork oak tree is never cut down, never felled, never killed. The bark is stripped by hand every 9 years using a curved axe by skilled workers called tiradors. They cut through the outer cork layer without touching the living cambium beneath. The tree is uninjured. Within days, the cambium begins regenerating new bark. Within 9 years, the bark reaches full thickness and is harvested again. The same tree produces cork for over 200 years, 16 or more harvests from a single organism across its lifespan. No replanting, no irrigation, no fertilizer, no pesticide. The tree grows on rocky hillsides unsuitable for agriculture, sequesters 73 kilograms of carbon dioxide for every kilogram of cork it produces, and supports one of the most biodiverse ecosystems in Europe: the Iberian lynx, the Barbary deer, the imperial eagle. Over 135 plant species per square meter beneath the canopy. Harvesting the bark does not reduce this biodiversity. It funds the management that protects it. This is the insulation material that the housing industry does not want you to know exists. A bark that outperforms fiberglass, refuses to burn, contains no chemicals, degrades nothing, lasts indefinitely, and regenerates from the same living tree every 9 years for 2 centuries. Now here is how they buried it. The archive opens in ancient Egypt, 5,000 years ago. Fishermen along the Nile are building boats from papyrus reed. They need a material to seal hulls against water. They find it growing on trees along the North African coast. The bark peels in thick slabs without killing the tree. It is lighter than any wood. It repels water completely. They line their vessels. They seal grain jars. They insulate floors in flood-prone dwellings. They do not understand the cellular structure. They understand the result. Rooms stay cooler in summer and warmer in winter. When the bark lines the floor and walls, by the 4th century before Christ, the Greeks name it pheles. They use it for sandal soles. They plug wine amphorae with it. They line the walls of homes in northern provinces and discover that interior temperatures remain stable when exterior temperatures swing between extremes. Aristotle observes its peculiar ability to trap air within itself. The Romans expand its use across an empire. They insulate aqueducts to regulate water temperature over miles of open channel. They wrap hot water pipes and find heat retained for hours longer than bare systems. They line roofs in northern Gaul. Pliny the Elder documents in his natural history that the bark regenerates after stripping and can be harvested repeatedly across the life of the tree without damage. He records trees in Iberia stripped for generations that continue thriving. For 3,000 years across 3 civilizations, cork was understood as the superior insulation material available to builders. It was understood because it was obvious. No other material matched its combination of thermal resistance, fire resistance, water resistance, longevity, and renewability. Then the petroleum age arrived, and the obvious became invisible. Then in 1938, a man named Harold Boschenstein walked into a factory in Toledo, Ohio, and made a decision that would keep petroleum in your walls for the next century. His company, Owens Corning, began industrial production of fiberglass insulation. Molten glass spun into fine fibers using petroleum-derived binders, cheap to manufacture at industrial scale, easy to install in the wood-framed wall cavities standard across American construction. The product worked adequately. It filled a cavity. It slowed heat transfer. It was not remarkable, but it was controllable. It could be manufactured in a factory. It could be patented in formulation. It could be distributed through a supply chain owned by corporations. It could be degraded by moisture and compression, creating replacement cycles. It could generate recurring revenue in ways that bark stripped from a tree never could. By the 1950s, fiberglass dominated the American insulation market. Building codes formalized around its specifications. Contractors trained on its installation. Supply chains locked in. Testing standards were written by the companies that manufactured it. The system closed around a single product category derived from petroleum and silica manufactured in energy-intensive plants and sold at margins that funded lobbying, code committee representation, and industry research grants. Here's what should make you furious. In 1964, the American Society for Testing and Materials established Committee C16 for building insulation standards. Of the 47 founding members, 31 represented fiberglass or mineral wool manufacturers. Not a single representative of cork, not a researcher, not an importer, not an architect who had used it. The standards that committee wrote are still in force today. Cork was never banned. Cork was never declared inadequate. Cork was simply never invited to the table where the rules were written. It vanished from American construction not because it failed any test, but because it was never allowed to take one. Today, the global building insulation market is valued at $37.7 billion. The United States alone accounts for $14.13 billion, projected to exceed $21 billion by 2034. Growing at 4.5% annually, Owens Corning, Johns Manville, Kingspan, Rockwool, these companies dominate. They manufacture fiberglass, mineral wool, polystyrene board, and spray polyurethane foam. Every product is manufactured from mined minerals or petroleum derivatives. Every product involves chemical synthesis. Every product degrades over time and requires eventual replacement. Every product generates the recurring revenue that sustains a publicly traded corporation. Cork requires a tree, a man with an axe, 9 years of patience, and nothing else. Spray polyurethane foam is the industry's premium product. Our value of 6 to 7 per inch. Superior thermal performance on paper, but manufactured from methylene, diphenyl disocyanate. Isocyanates that the EPA has documented cause occupational asthma severe enough to kill sensitized workers. Homeowners are advised to vacate structures for 24 to 72 hours after application. The product off-gases volatile organic compounds for months. When improperly mixed, it never fully cures and continues releasing toxic vapors indefinitely. It cannot be removed without destroying wall cavities. It cannot be recycled. It cannot be At end of life, it enters landfill permanently. It is derived entirely from crude oil, and it costs 3 to 4 times more per square foot than cork insulation boards shipped from Portugal. Fiberglass contains formaldehyde-based binders that off-gas into interior air. Studies have documented respiratory irritation, headaches, and elevated cancer risk from chronic low-level formaldehyde exposure in homes insulated with standard fiberglass bats. Workers handle it with respirators and full body protection. Homeowners breathe its emissions for decades without protection of any kind. Polystyrene rigid board is manufactured from petroleum. It melts at 350 degrees Fahrenheit. It releases hydrogen cyanide and carbon monoxide when burning. It degrades under UV exposure. It absorbs moisture over time and loses insulation value. Cork contains no formaldehyde. Cork releases no volatile organic compounds. Cork does not irritate skin, eyes, or lungs. Cork does not require respiratory protection during installation. Cork does not melt. Cork does not burn below 905 degrees Fahrenheit. Cork does not release toxic gas under any condition. Cork does not absorb moisture. Cork does not degrade under UV exposure. Cork does not lose insulation value over time. Cork has been measured performing at original R value after 100 years of continuous installation in Portuguese structures. Cork is 100% tree bark. It is manufactured using only steam and heat. No binder, no resin, no chemical of any kind. Then in 2017, the Passive House Institute in Germany published a 3-year study of cork-insulated buildings across Northern Europe. Average heating energy reduction of 61%. Zero moisture damage recorded after 15 years of monitoring. Zero off-gassing detected in air quality measurements taken inside occupied structures. The institute concluded that cork was the only insulation material in the study that improved in thermal performance over the observation period rather than declining. That study is public. Every American building scientist has access to it. Architects in Germany, Denmark, and Austria specify cork on passive house projects because the data is unambiguous. American architects were never taught it existed. The study sits unread in the same silence that has surrounded this bark for 80 years. Portugal produces 50% of the world's cork. 730,000 hectares of cork, oak forest, over 8,000 direct jobs. A billion-dollar industry built on bark that regrows every 9 years from trees that live 200 years and are never killed. The harvest season begins each May. Tiradores work through summer, stripping bark in slabs that are stacked, dried in the sun for 6 months, then processed into boards using nothing but steam, no glue, no resin, no binder, no chemical of any kind. The natural suberin within the cork cells melts under steam pressure and fuses the granules into rigid boards. The finished product is 100% bark. Here's what you can do right now. Expanded cork insulation boards are available from specialty importers who ship directly from Portugal. Standard thicknesses of 1 to 4 inches, standard panel sizes that fit between studs or apply directly to exterior sheathing. Installation requires no special tools, no respirator, no chemical mixing, no evacuation of the home. You cut it with a handsaw. You fasten it with standard screws or adhesive. You breathe freely while you work. Your children can be in the next room. The product costs approximately $6 to $8 per square foot for tunch panels, comparable to premium spray foam installation when labor is included. The difference is that spray foam degrades and must eventually be replaced. Cork does not. Over the lifetime of a structure, cork is the cheaper material, but lifetime cost calculations do not appear in quarterly earnings reports. Replacement cycles do. You will not find cork insulation at Home Depot. You will not find it at Lowe's. Your contractor has never installed it. Your building inspector has possibly never seen it. Your architect was never taught it in school. Not because it fails any performance standard. It exceeds them, not